Today we are going to cover our other bonus trig section, which would be the law of cosines. The law of cosines will help us again find sides and angles of triangles that are not necessarily right triangles. It will also help us when we cannot use law of sines by what was given to us initially. Alright, for our warm-up, we are solving for A, which means we really just need to simplify the right side and then do what? Take the square root of it. So, sounds easy. Really, it's not too terrible. I'm going to show it kind of one step at a time. So, 23 squared was 529. 26 squared was 676. Minus, now this whole next part you could type into your calculator all at once. 2 times 23 times 26 times cosine of 43. And what do we get? Let's take it out to 3 decimal places. Okay. I don't like to round too much until the very, very end. So on the right side now, to simplify it, we've just got addition and subtraction. So that could all go in your calculator. 529 plus 676 minus, I'm just going to use my second answer function to get that 874.699 in there. And what do we get for that? That's not.
Oh wait, that's the I added those and then subtracted. Where you get 874? Because I added both of them.
We got the 874.669 when we multiplied 2 times 23 times 26 times cosine 43. Did we all agree with that part?
Yeah. I added both of those. 520 and 676 and subtracted them. That's what I got.
What else did people get? So we haven't square rooted yet. Because I'm showing 330.3, 0, 0, and some. Oh. Are we okay with 330.3? Anybody not getting that before we square root? Last step to get A all alone would be to square root both sides. And A equals square root 18.2? We okay with that? Yes, ma'am. 529 plus 676 minus 874.699. You what? Yep, I did all of it. Other questions, concerns? Because a lot of what we're doing today will involve simplifying things that look like this. We're ready to move on? Mm-hmm. Okay. So we used the law of sines when we didn't have a right triangle and we knew at least one angle with its opposite side. We had one pair matched up, so to speak. We're going to use law of cosines for non-right triangles and when we can't use the law of sines. There are two possible scenarios for using the law of cosines. One case would be an angle and its opposite side are not both given. The other case would be we are given all three sides, but not given any angles. In either one of these situations, we would not be able to use law of sines. Law of cosines gives us three different equations. You will probably notice a pattern. They're all pretty similar to each other. First, a squared equals b squared plus c squared minus 2bc times cosine of a. I won't read all of them out. However, you'll notice that whichever side is alone on the left side is the same letter as the angle that you're taking the cosine of. We see that? B is the side that's by itself, even though it's getting squared. B is the angle that we've got for cosine. Same thing on the last one for C. The other two sides are used twice on the right-hand side. So B and C are both squared and added minus 2BC. So there's always a pattern that these follow. Okay, so we are going to go through some problems with both of the cases. So one where we don't have a pair of angle and opposite side together. One where we only are given angles, we aren't given any sides. What I will tell you though is that even if we have to use law of cosines initially, as soon as you're able to, you will want to switch over and use law of sines instead. So as soon as you are able to find an angle or a side that gives you a pair of like angle B and side B, as soon as you're able to, you are going to want to switch over to using the law of sines. So first up is our case 1. And our advice is that generally you start using the formula that finds the side you don't know. So even though we are eventually looking for an angle, we are going to start off finding the side that we don't know. Alright, so you should have already started. As Caleb mentioned, we don't know side B. So the one we're going to focus on is b squared equals a squared plus c squared minus 2ac cosine of angle B. So the angle behind cosine should match the side that we're solving for on the left. Okay, so we start plugging things in. We don't know b squared. We do know a is 14. C is 2. So those get plugged in for both a's and c's. And we know that angle B is 60. So this is why our warm-up was what it was, so that you could get some practice. Okay, now some of this you could type into your calculator together, like 14 squared plus 2 squared. Most people would be able to type that into their calculator at the same time. What's 14 squared plus 2 squared? 200. Okay, now if you need to do them all out separate, that's fine. I'm just trying to shorten it up a little bit, but not too much at a time. If you try to do too much in your calculator at a time, probably an error will get made at some point. Another thing you could do would be 2 times 14 times 2, which would give us 56 cosine 60. At this point, most people probably could type in 200 minus, You might want to do some like extra parentheses around the 56 times cosine of 60, or do it in two pieces. But if we simplify that right side down to a single number, what do we get? So it's still b squared. I haven't square rooted anything. 172 is what I got when I did it. Does anybody need help getting the 172? To get b all alone, of course, we need to square root. Now, on these problems, remember, I don't want to round until we get to the very end. So I would leave b as the square root of 172. Or, if you really want to simplify it, you can. It would simplify, I believe, to 2 root 43. Okay, I would use one of those. I would not round a decimal on this. We are not far enough into the problem to be rounding. I'm not saying it wouldn't work out. I'm just saying you're risking your answer being off by a few decimal points probably. Questions about getting side B? Okay, now that we have side B, we also have angle B. So once we have a pair of a side and the angle across from it, we can switch over and use law of sines instead. Does this make sense? Which is what we've done the last 2 days. So remember, one of your ratios, you need to be able to fill in everything. So the sine of 60 over 2 root 43, or you could use root 172, is equal to sine of, which angle did we want to find? Angle A. So that would have to go over 14, the side across from it. Questions about our law of sines setup? Okay, from here, this should be pretty easy because we've spent a couple days practicing these types of problems. We cross multiply 2 root 43 times the sine of A is equal to 14 times the sine of 60. The next thing we have to do is divide both sides by 2 root 43. And then after that, we would need to use inverse sine to get A all alone. Now, again, you'll have to be a little careful how you type this into your calculator, but you should have, hopefully at this point, learned your calculator well enough to know what works for you. Let's round measure of angle A to the nearest tenth. What do we get?
A fraction that has a square root.
After you took inverse sine? Okay, when I did it, I got 67.6, so I believe that would be correct. Anybody need help getting that? Last call for questions on this one before I move on to the next one. Okay. The next one is the same type of situation. We are looking for the measure of angle B. The information given to us does not give us a matched up pair of opposite side with its angle. So we are first going to find what? Side C. Okay, we're first going to find side C, and then we would have an angle side pair, so we can switch over to law of sines. So C squared is equal to A squared plus B squared minus 2AB cosine angle C. The first thing I do is just plug everything in. And yes, I will want to see that step. We use our calculators a lot on these, but I still want to know your initial setup, just plugging things in. So first I'm going to take 21.5 squared plus 13 squared. I am not going to do any rounding just yet. What do we get for just that part, those first two numbers squared and added together? Okay, 631.25 minus 2 times 21.5 times 13 gives me 559 cosine 78. Are we all okay there? Okay, now on this one, we might not be able to avoid the fact that we're going to have to round a little bit before the end. So if we take 631.25 minus 559 times cosine of 78. Let's leave it at 4 decimal places for now. What do we get for c squared? 515.0274. Questions about getting there? Okay, and then of course we are going to square root that, which I just left that number in my calculator and did square root of my answer. If you're still not sure how to use the answer function on your calculator, I would be asking about that because it's very useful on these problems. So I'm still not going to round it too much. What did we get to forward places? Okay, that's what I got. Questions about just getting side C? Yes.
Like, so can we always use the decimal form for equations? Because last time we didn't.
So last time we didn't get, so last time it wasn't ugly. Like your calculator should have given you a radical form of it. As soon as we typed in cosine of 78, it gave us a decimal that we had no way around. Last time when it was cosine of 60 degrees, it didn't give us a decimal at that point, which made our numbers nicer. Does that make sense? Yeah. Okay. So cosine of 60 isn't going to give us as ugly of an answer as cosine of some other random angle. Angles like 45, 30, 60, those will usually avoid decimals for us.
If we were to use square root of 516, now that we said, would it still have the same answer?
In the very end?
Yeah.
Maybe. I haven't tested it out. But I don't suggest rounding too much until the very end, just in case it gets you off by a tenth. If it gets you off by a tenth here, it could mean your answer's off by more later. So I would not recommend rounding very much till the end. Okay, other questions? All right, so now that we have side C, we can switch over to using our law of sines. We know in one of our ratios, we need to be able to fill in numbers on the top and the bottom. So we would use the sine of 78 over, okay, that decimal we just found, 22.6942. If we are looking for the measure of angle B, we should have sine B in our other numerator. Our other denominator would be 13. Okay, we have to cross multiply and solve. So 22.6942 sine B is equal to 13 times the sine of 78. Same process as last time. We're going to have to divide and then use inverse. So B is equal to inverse sine of that whole fraction. Again, if you need to do the numerator, get an answer. Divided by denominator, get an answer. Then do your inverse sine. Do it that way. For some calculators, it's easier to do that than to try to type it all in at the same time. What did we get? 34.1 degrees. That's what I'm getting to. Anybody need help getting that? We're sure? Warm, fuzzy feelings all around? Anybody need more time on this one before we go on to our next case? Okay, next case. Case 2, you've got all the sides, but you don't have any angles. First thing you want to do is find the largest angle using the law of cosines. As soon as we're able to, which would be step 2, switch to the law of sines and find the second largest angle. Lastly, we can find the third angle by subtracting the other two angles from 180. On the last couple problems, we did not show a triangle or a diagram. For this case, you might want to. I'm not saying it's required, but you might want to be able to visualize which angle is supposed to be the smallest, the largest, the next largest, and the smallest. Does anybody need more time filling in their blanks? Okay, then let's give this a try. We are solving the triangle, which means we're trying to find any information we don't know. In this case, that would be all three angles. So we draw a generic triangle. I actually don't really care what your triangle looks like. I care more about how you label it. So if side C is 7, B is 6, A is 5, it might even help to put like A equals, B equals, C equals next to them. The largest angle is going to be across from what? The largest side. So our biggest angle in this case is going to be angle C. Of course, you should be labeling the angle across from the side with its capital letter. So this would be angle C. For the way I drew it, my angle at the top would be B, and the one on the left side would be A. We have questions about how I set up my triangle. All right, so our directions told us we are going to find the which angle? Largest angle. So we're trying to find angle C. So the version of the law of cosines that we want to use starts with what? C squared. So we are going to use the one that says C squared is equal to minus cosine C. If we're trying to find angle C, this is the version we have to use. Of course, we're just going to plug in everything we know. If you want to square these as you plug them in, I would kind of be okay with that. All right, C squared is what? 49 equals A squared. B squared. Okay, I believe most of you should know those. Minus 2 times 5 times 6 cosine C. I want you to be super careful when you are simplifying these and trying to get C alone. So, of course, we can simplify this by adding 25 and 36. We would get 61 minus 2 times 5 times 6 is 60 cosine C. Now, if our goal is to get angle C alone, what do you think we should do next? Adriana? Okay, subtract 61 would be what I would do as well. 49 minus 61 is negative 12. What do we have to remember when we write the other side? The 60 is a negative 60. Do not drop that sign. It will mess everything up. Next thing we should do. No. Divide by negative 60. Remember that we are multiplying that number to cosine, so we divide by negative 60. That will turn our number positive 0.2, or you could write it as a fraction, which would be 1/5. Either way, I'm going to continue my work up here since I'm running out of space. So what I've got right now is that 1/5 is equal to cosine of C. To get C all alone, we would have to use inverse cosine. So inverse cosine of either 0.2 or 1/5, it's the same thing, is equal to angle C. And what do we get? 78.5 degrees. Measure of angle C is 78.5. Questions, concerns about that angle? Okay, we found the first angle. That was step 1. Step 2 is to now use law of sines to find the next biggest angle. So we know that one of our ratios has to be the one where we know the angle and the side across from it. So sine of over, okay, angle, sine of angle C over C is equal to, our next biggest angle is going to have to be B, so the sine of B over, how did we know B would be the next biggest angle? Okay, 6 is bigger than 5, so remember that the biggest angle is across from the biggest side, middle angle is across from the middle side, smallest angle is across from the smallest side. This should be familiar to us. We've done this many times now. We cross multiply 78.5, then we would have to divide, and after we divide we have to use the inverse sign. So B is equal to inverse sign of that fraction. Again, at this point, you should be knowing what you're comfortable doing with your calculator. If you need to do one step at a time, that's fine. If you are confident that you know how to type it all in at the same time and get the answer to come out correctly, that's fine. What do we get for angle B? 57.1 degrees. I'll write that all the way at the bottom. 57.1 degrees. The last angle should be the easiest to find. How'd you get it? Okay, so to get our last angle, we're going to take 180 minus the angles we already know. What did we say we got? 44.4 degrees, and that would be angle A. So we have all of them. When you're doing this, if your work looks like what mine does, I will need you to either write your answers in your triangle so that I can find them inside of your diagram, or make sure they are clearly boxed off. Does that make sense? You need to make it easy for me to identify your answers. If I have to hunt for it, you're probably not getting your points. Questions about law of cosine?